Hi, I'm Lorna Williams, a trained mathematics teacher. Welcome back to my channel, Bloom Your Math, and A is your grade. Now, in this video, you will learn all about equality of matrices, singular matrices, non-singular matrices, determinants, and how to calculate the inverse of a matrix. So, stay tuned. Let's start with equality of matrices. Now, two matrices are equal when two things. They are of the same order, their corresponding elements are equal. So here are two matrices, one on the left, one on the right, and an equal sign in between them. Now, again, kind of the same concept as when we were adding two matrices. A is in the same position as W. So A is equal to W. B is in the same position as X. So B is equal to X. So you can't have 4 here and negative 1 here. That don't make sense. The numbers must be the same. The values are the same. If this is 5, then this has to be 5. Understand? Okay. So here we see that A equals X. A equals W. B equals X. C equals Y, because they're in the same position, and D equals Z. That's all you really know, that you need to know that they are of the same size, 2 by 2, 2 by 2, and their corresponding elements are equal. In other words, they're in the same position. So moving on, I'm giving you a simple example until we reach your past paper Take 5 series. Given that 2x 4 negative 3y equals negative 2 4 negative 3 6, find the value of x and y. Again, they're in the same position, meaning that 2x is equal to negative 2. They must work out to be the same. They already give us that negative 3 is equal to negative 3, so we need not touch that. That is very obvious. And 4 is equal to 4. So obviously, we know the value of y because y is in the same position as 6. Here is the answer. So the only one that we really need to show working with is 2x equals negative 2. So here we go. 2x is equal to negative 2. Again, we are multiplying here. So in order to make x stand alone, we do the opposite by dividing. And if you divide one side by a number, you have to divide the other side by the same number to maintain balance. That's what the equal sign means in math. Alright, so here we go. We divide both sides by the coefficient or the number before x, because we want 1x or x. And 2 into 2 goes 1. Negative, there's a positive in the denominator. A positive divided by a negative is a negative. So x is equal to negative 1. Here's a 1. Alright, let me use a blue marker so we don't get lost to cancel. 2 into 2 goes 1. And so a negative divided by a positive is a negative, and you're only left with 1 there. So the answer is negative 1. Hope you got that. Here is the answer. But I always like to show the balance method where you divide both sides by 2. You could also do it this way. Alright, whichever makes you feel comfortable. You see, there are so many ways of doing one question. So whatever makes you happy, you use that. Determinants. Now consider the matrix 3, 2, 4, 10. The determinant of the matrix is calculated as follows. And we're going to be using these two lines to show that we're about to calculate. And here we go. I'm going to circle 3 and 10. These are called the main diagonal, right? And the formula for calculating the determinant is AD minus BC. So the main diagonal is AD, and the minor diagonal is 4 times 2, 4 to 2. So this is a minor. Some people say leading diagonal for main and non-leading for minor. And we just simply multiply 3 times 10 minus BC. So this is B and this is C. Come again. A times D minus B times C is how we calculate the determinant of a matrix. Okay? So it's 30 minus 8 will give me 22. So generally the determinant of a matrix is given by AD minus BC, as we said before. And in the matrix A to D is called the main diagonal. That's your notes. Again, pause the video and take your notes. A to D is called the main diagonal of the lead or the leading diagonal. So main diagonal, that's the main, right? And C to B or B to C doesn't matter the order because you're multiplying. 4 times 3 is the same as 3 times 4. So if you say C times B or B times C, you'll still get the same answer. This is the minor or the non-leading diagonal. So what's the formula then for calculating the determinant? It's a main diagonal product, A times D, minus the minor diagonal product, C times B. Okay? Alright, so that's A times D minus B times C or C times B. And if you want to say D times A, but we usually write them in alphabetical order. A comes before D in the alphabet. But if you write DA, it's not wrong. It means the same thing. Moving on. What is a singular and non-singular matrix? A singular matrix is a matrix whose determinant is equal to 0. Therefore, AD minus BC must be equal to 0. Now, in matrices, the opposite of singular is not plural. We're not dealing with English. Maths has its own jargon. So, a non-singular matrix, the opposite of singular, is non-singular. Okay, the opposite of singular is non-singular. A non-singular matrix is a matrix where the determinant is not equal to 0. So the formula now would be AD minus BC is not equal to 0. In our Take 5 series, we will work more challenging questions, but I want you to get the main concepts today. We're taking it one step at a time, okay? So example 1, evaluate the determinant of 4263 and state whether the matrix is singular or non-singular. Again, we all know the formula, so we know that this is A, top left, and B, bottom right. This is C and D. So that's 4 times 3, which we have here, minus the non-leading or the minor diagonal. And you know what a diagonal is? Let me just draw a rectangle. That's a diagonal. So if you notice how I draw the circle, it looks like a diagonal, doesn't it? Okay, see. And there's another diagonal here, So we're looking at two diagonals. Let me use the red. So there are two diagonals here. And the blue diagonal is AD. Alright, so the blue diagonal is AD and the red diagonal is BC. Don't get them mixed up now. We start with the A, top left. Bottom right is D, not B. Okay? Dog, not boy. Alright, and state whether the matrix is singular or non-singular. So we multiply 4 by 3 because this is AD and B times C. And if we get 0 for the answer, it means that that matrix is a singular matrix. So we write that the answer is 0 and it is a singular matrix. Now where are we going with all of these notes? Very important that we're heading to solve simultaneous equation using a matrix method. So all that you see we're doing here are notes providing you or helping you to move a step further, especially determinants. Okay? Let's see if I jump too far or okay, let's go. Example 2. If find x. Now this time they give you an unknown, a variable, and they tell you that the matrix is singular. This is a frequent past paper question. Now if it's a singular matrix, then you know that the determinant has to be equal to 0. So you could write your formula here, AD minus BC equals 0. I didn't have it on the slide, but you can write that in for me. AD minus BC. So this is A, and this is D, and B is 6, and C is 2. Okay? So A multiplied by D is x times 3, and B multiplied by C is 6 times 2. X times 3 is not x3, no. We write the number first, 3x. So the coefficient of x here is 3. Okay? Minus 6 2's, 12 equals 0. 3x is equal to 0. We are adding 12 to both sides. So 3x is equal to 12. Some people say we carry over minus 12. But we don't really carry over anything, you know. We're actually adding 12 to both sides to maintain the balance of the scale. Alright, so 3x equals 12. And again, even though I have this here, my preference is just to show that in order to make x a subject, I do the opposite here of multiplication, which is division. So I'm dividing both sides by 3. So 3 into 3 goes 1, and 3 into 12 goes 4. So I really prefer this working. Alright? So either way is fine with me, but you will get this concept, especially when you're doing questions like changing the subject of a formula where you're working with letters only. So I encourage you to use this method. I'll just give you a quick preview. If I say AX is equal to B, and you want to make x a subject, then clearly you need to divide both sides by A. A divided by A is 1, just like how 5 divided by 5 is 1. So x is equal to B over A. So that's why I encourage this method, because it's easy when you're doing transposition, which is the same as changing the subject of a formula. Okay? Awesome. Moving on. Two by two adjoint matrices. Given the 2 by 2 matrix A equals A, C, B, D, the adjoint of the matrix is obtained by interchanging the main diagonals and multiplying the minor diagonals by -1. So So the leading diagonal or the main diagonal, as I said before, always starts with the top left. It starts with the A. So let me show you a practical example here. An easy example. Find the adjoint of the following: 4, 1, 7, 3. All those numbers are positive numbers, as you can see. So step 1 says, for you to find the adjoint, the first thing you need to do is to interchange the elements of the leading diagonal. In other words, 4 and 3 exchange positions. So where the 3 was, you put 4, and where the 4 was, you put 3. That's why I have 3 here, and that, yes. So coming back, I lost a while ago. That's the question. So I'd like to write the word question so we don't get lost. We're finding the adjoint of 4, 1, 7, 3. So this is the main diagonal, 4 and 3. So we exchange positions with them. So the 3 takes the place of the 4, and the 4 takes the place of the 3, which is what we have here. And step 2 says, multiply the non-leading diagonals, that are the other two numbers, by -1. So this 7 and this 1 are being multiplied by -1. But notice, they still keep the position. We don't switch them. They keep the position, but they just change the sign. So this is the final answer for the adjoint. And let's give it a letter, because we use capital letters to name it. Let's call this, we always use X, so let's call it Z. So the adjoint for Z is 3, -1, -7, and 4. Is that clear? Alright. So follow those 2 steps to find the adjoint. I'll pause a while so you can take your notes, or take a picture, or write the notes. Alright, moving on. Inverse of a non-singular matrix. Now, the abbreviation for the inverse of a matrix is A to the -1. It's a power. A, and I keep forgetting that the black marker is the writing. So, let's give that a break. He's taking a seat. A to the -1 is the inverse. And the formula for inverse is 1 divided by the determinant times the adjoint. So if I ask you to find the inverse of a non-singular matrix, what do you think you're required to find? Obviously, you want to find the determinant and the adjoint. So let's look at an example. Determine the inverse of the non-singular 2 by 2 matrix. Now remember what a non-singular matrix is. The determinant must not be equal to 0. And I'll explain that in future videos, why I say non-singular and not singular in this question. So here we have a matrix called A, 2, 1, 3, 5. And we are determining now the inverse. So first we calculate the determinant, which is AB minus BC. So this is A and this is D. That's why we get the 2 times 5. Right? Let me write the A so it looks like an A and not a Q. Alright. And then BC, again, it doesn't matter if you want to write the 1 or the 3 before. We're multiplying these 2 numbers. Because remember, the commutative law says that 4 times 3 is equal to 3 times 4. The order of operation for multiplication does not matter. 12 is equal to 12. True. Okay? But is putting on your socks and then your shoes the same as putting on your shoes and then your socks? No, that's not commutative. Does it work for addition? Yes, it does. 4 plus 3, is that equal to 3 plus 4? Yes, 7 is equal to 7, so that's a commutative law. Alright? And I gave you that in your homework, and I will be posting the solutions in the description box, so check that out, please. So we just found, or we just calculated the determinant, and our answer is 7. What do you think we need to find next? Yes, the adjoint. And how many steps do we need to use to calculate the adjoint? We just discussed it. 2 steps. Here are they. Let's go back to the question. The question says 2, 1, 3, 5. Don't ever lose it. So let me write it up here. 2, 1, 3, 5. That's the question. Alright, so start calculating the inverse now. 2 and 5, that's step 1. 2 and 5 exchange position. So 5 is here and 2 now is right at the bottom right. And what do we do with the other 2 elements? They stay same place, they don't move, don't touch them. But what happens is that we change the signs. So they were positive 3 and positive 1, now they become negative 1, negative 3. So what did we say the formula for finding the inverse? A to the minus 1, okay, is 1 over the determinant multiplied by the adjoint. 1 over the determinant times the adjoint. So remember, let me go back. What did we say is the answer for the determinant? 7. What did we say is the answer for the adjoint? 5, negative 1, negative 3, 2. So let's put everything together now. 1 over the determinant 7 times, and we use brackets for times, the adjoint. And this is the answer for the adjoint. And if you want to write it as a fraction, if you want to show your answer as a fraction, then basically what this means is that we are multiplying, this 7 is now a scalar, and we are multiplying that scalar by every element inside the bracket. So we have here 1 times 7 times 5, sorry, 1 over 7 times 5, 1 over 7 times negative 3, 1 over 7 times negative 1, and 1 over 7 times 2. Okay? Each of the elements in the matrix is being multiplied by 1 over 7. Now if you recall, if I give you 2/3 times 6 over 7, this can cancel. 3 into 6 goes 2. So our answer is 4 over 7. But if we're working 1 over 7 times 5, nothing can be cancelled. 1 over 7 times, alright, let's use another example before I get there. Suppose you have 2 over 5 times 7 over 9. That's multiplication of 2 fractions, right? So nothing can be cancelled. So we multiply numerator by numerator. 7 2s, 14. Denominator by denominator. 5 times 9, 45. Can't be simplified any further. So if I am multiplying, if I'm trying to work this, 1 over 7 multiplied by 5, we can turn 5 into a fraction by putting it over 1. Notice, nothing can cancel. Of course, 1 can cancel 1, but we're here and not there with that. So we simply multiply numerator by numerator. 1 times 5 is 5, and denominator by denominator. 7 times 1 is 7. That's the simplest form. One last example of how we get the answer for this, because that's how we get the 5, 7. Let's see how we get the negative 3 over 7. 1 over 7 times negative 3 over 1. Nothing can be cancelled, so we multiply numerator by numerator. Negative 3 and denominator by denominator. 7 times 1, 7. That's how we get our negative 3, 7. So I think this is pretty clear. So you may ask, how do you leave your answers? Sometimes we leave our answer in this fashion, and sometimes we leave it as a fraction. It depends on how CSEC asks the questions, but I will expose you to both ways of how they can present a question on inverse in our next video. So that's it for today's class, guys. I post 2 videos every week. And if you like this video, please like, share, and subscribe. You may ring the notification bell just to alert you when I upload new videos. So, I'll see you next time. Bye.